Have you ever looked up at the night sky and wondered what lies beyond our planet? Since the dawn of time, humans have been fascinated by the stars. We've longed to explore the cosmos and uncover its secrets. This desire has fueled countless stories, myths, and scientific endeavors. One of the most captivating dreams is intergalactic travel, the idea of venturing beyond our Milky Way galaxy to visit other star systems. This dream, however, faces enormous challenges. The vast distances between galaxies and the limitations imposed by time present formidable obstacles. Imagine trying to cross an ocean in a tiny boat. That's a simple analogy for the scale of intergalactic travel. Despite these hurdles, the human spirit refuses to be deterred. Scientists and engineers continue to push the boundaries of technology, seeking innovative solutions to overcome these cosmic barriers. The pursuit of intergalactic travel is a testament to our insatiable curiosity and our determination to understand our place in the universe. The journey begins with understanding the sheer scale of the cosmos and the hurdles we must overcome. Join me as we embark on a journey to explore the challenges and possibilities of intergalactic travel. The first challenge of intergalactic travel is grasping the immense distances involved. Our galaxy, the Milky Way, is about 100,000 light-years across. That means it would take light, traveling at an incredible speed of 300,000 kilometers per second, 100,000 years to cross it. But the Milky Way is just one galaxy among billions in the observable universe. The nearest major galaxy to ours is Andromeda, a staggering 2.5 million light-years away. To put this distance into perspective, if we could travel at the speed of light, it would still take us 2.5 million years to reach Andromeda. These distances are difficult to comprehend on a human scale. We're used to measuring distances in miles or kilometers. In space we use light-years, the distance light travels in a year. Even this unit seems inadequate when discussing intergalactic travel. The numbers are simply astronomical. To overcome this distance barrier, we need to develop revolutionary propulsion systems that can achieve speeds far exceeding anything currently possible. Even then, the journey times would be incredibly long. This leads us to the next significant hurdle time. The speed of light, while incredibly fast, is also a fundamental limit in the universe. According to Einstein's theory of relativity, nothing can travel faster than light. This limitation has profound implications for intergalactic travel. Even if we could build a spacecraft that could travel at a significant fraction of the speed of light, the journey to another galaxy would still take thousands if not millions of years. This presents a significant challenge for human travelers. Moreover, time itself behaves differently at speeds approaching the speed of light. Time dilation, a consequence of relativity, means that time slows down for objects in motion relative to stationary observers. So while a journey to a distant galaxy might seem short for the travelers on board a near-light-speed spacecraft, thousands or even millions of years would have passed back on Earth. This time, discrepancy creates a paradox. If we were to send a mission to another galaxy, generations of humans would live and die during the journey. The original travelers would never reach their destination. Their descendants, born into the confines of a spacecraft, would inherit the mission. The time barrier is perhaps the most daunting challenge of intergalactic travel. It forces us to confront the limitations of human lifespans and the vastness of cosmic timescales. Despite the challenges posed by distance and time, scientists and engineers are actively exploring ways to overcome these barriers. Current spacecraft propulsion systems, however, are woefully inadequate for intergalactic travel. Chemical rockets, which rely on burning fuel, are simply too slow and inefficient. To achieve the immense speeds required for intergalactic travel, we need to look beyond conventional propulsion. Some of the concepts being explored include nuclear fusion. Harnessing the power of nuclear fusion, the same process that fuels the stars, could provide a much more efficient and powerful source of energy for spacecraft. Antimatter propulsion. Antimatter, when it comes into contact with ordinary matter, annihilates and releases tremendous energy. Antimatter propulsion is a highly theoretical concept, but it holds the potential for incredible speeds. Solar sails. Solar sails utilize the pressure of sunlight to propel spacecraft. While not practical for intergalactic travel due to the diminishing intensity of sunlight, solar sails are being considered for interstellar travel within our solar system. These are just a few examples of the innovative ideas being explored. The development of new technologies is crucial for overcoming the distance barrier in intergalactic travel. Section 5. The challenge of surviving the cosmos. Even if we could develop spacecraft capable of reaching other galaxies, ensuring the survival of the crew during these incredibly long journeys presents another set of challenges. Space is a harsh and unforgiving environment. Here are some of the key challenges. Life support. Creating a self-sustaining environment within a spacecraft that can provide food, water, and breathable air for decades, if not centuries, is a monumental task. Radiation shielding. Space is filled with harmful radiation both from the sun and from cosmic rays originating outside our solar system. Protecting the crew from this radiation would require advanced shielding materials and technologies. Psychological effects. The psychological impact of long-duration space travel on the crew would be significant. Confinement, isolation, and the stress of such a mission could have detrimental effects on mental and emotional well-being. Addressing these challenges is crucial for the success of any intergalactic mission. It requires a multidisciplinary approach, drawing on expertise from fields like engineering, biology, psychology, and medicine. Section 6. Wormholes and warp drives, science fiction or reality. While the challenges of intergalactic travel seem insurmountable with our current understanding of physics and technology, some scientists speculate about the possibility of exploiting exotic phenomena that could allow us to circumvent the limitations of distance and time. Wormholes are theoretical tunnels that connect two distant points in space-time, essentially creating shortcuts. While predicted by Einstein's theory of general relativity, wormholes remain purely theoretical. Even if they exist, the technology required to create and stabilize a wormhole is far beyond our current capabilities. Warp drives, a staple of science fiction, involve warping space-time itself to achieve faster-than-light travel. The idea is to compress space-time in front of the spacecraft and expand it behind, creating a warp bubble that allows the craft to move faster than light without violating any laws of physics. However, warp drives are highly speculative and there is no guarantee that they are physically possible. While these concepts are intriguing, it is essential to remember that they are purely theoretical. Much more research and technological advancement are needed before we can determine if they are viable options for intergalactic travel. Section 7. The ethics of intergalactic exploration. The possibility of intergalactic travel also raises profound ethical and philosophical questions. If we were to encounter other intelligent life forms in our galaxy, how should we interact with them? Should we attempt to make contact, or should we observe them from afar? The vast distances involved in intergalactic travel also raise questions about the purpose and justification for such missions. The resources required for intergalactic travel would be enormous. Are the potential benefits of exploring other galaxies worth the costs and risks? Furthermore, if we were to establish a presence in another galaxy, we would have a responsibility to minimize our impact on any existing ecosystems or civilizations. The principles of planetary protection, developed for exploring our solar system, would need to be extended to a galactic scale. The ethical implications of intergalactic travel are complex and multifaceted. They require careful consideration and open dialogue as we continue to explore the cosmos. Section 8. The future of intergalactic travel. While intergalactic travel remains a distant dream, our fascination with the cosmos continues to drive innovation and push the boundaries of human ingenuity. The technologies we are developing for space exploration have applications here on Earth, leading to advancements in fields like materials science, energy production, and communication. In the coming decades and centuries, we can expect to see continued progress in space exploration. Missions to Mars and the outer solar system will help us to develop the technologies and expertise needed for longer-duration space travel. As we learn more about the universe and our place in it, the dream of intergalactic travel may become more attainable. The pursuit of this dream, even if it remains elusive, inspires us to reach for the stars and to never stop exploring the unknown. Section 9. Conclusion. A universe of possibilities. The universe is a vast and mysterious place filled with wonder and endless possibilities. The challenges of intergalactic travel are daunting, but they are not insurmountable. Human history is a testament to our ability to overcome seemingly impossible obstacles through innovation, collaboration, and a relentless pursuit of knowledge. While we may not achieve intergalactic travel in our lifetimes, The pursuit of this dream expands our understanding of the cosmos and inspires future generations to continue exploring the universe we inhabit. The journey of 1,000 miles begins with a single step, and the journey to the stars begins with a single dream.